So what is business analytics? So if I look at the definition which is provided here, it tells me study of business data using statistical techniques and programming for creating decision support and insights for achieving business goals. But if you look at this definition in parts, one is it involves study of data and business data. So we all understand that. Statistics and programming, this is very important, right? So, you need to understand statistics as well as programming. So nowadays there is so many tools and programs and methods available to do statistical work. But if you are not a programmer, if you don't know the basics of programming, probably you can't use this to the best of its potential, right? So that is where statisticians with no programming experience do feel a certain handicap in the area of business analytics, and the same goes with programmers who have no statistical technique in the statistical background. So though you may know how to program, you may know how to call the functions, you feel handicapped by your basic understanding of statistics, and I'll go into why that is very, very critical. So these two things, the statistics and the programming, goes hand in hand. For creating decision support, right? So whether you do prediction or you do optimization or you do some, exploratory analysis, what we are really doing is creating decision support. So in business, every day you have to take decisions. And for all these years, a lot of these decisions one used to take by, you can call it intuition, experience, discussions among, various people with the expertise and the skills. It will have an exact science. So why today? Why suddenly are we talking about data-driven decisions? Yeah, so that is the question. So the world is now moving towards a stage where these decisions are more and more taken with the support of data, because no matter how experienced, how much knowledgeable you are, intuition may always be wrong. There is a lot of thrust, there is a lot of focus that we want to take decisions which is supported by data. And why today? Because of a number of reasons. One is a lot of data is available today, and you are aware of that, right? There is a lot more data which is being collected today all over in every domain. And the ability to work with that data. So IT infrastructure, with cloud computing, with the data centers, today there is a support for you to work with a huge volume of data. And thirdly, there is so much of tools. Like, so a few years ago it was probably just a few tools which people had to depend on. Today there are so many tools in the market which makes it possible for you to easily start using data for your business problems or business issues. So that is where we say that business analytics plays a role in helping you take decisions or decision support and insights for achieving business goals. And this is also very important. What is the purpose? What is the purpose of all this modeling? What is the purpose of all this collecting data, running so many models? So never to lose sight of the goal. And this is where domain knowledge plays a big role. Sometimes, I'm thinking of an example here. So when I started doing my analysis career, so we were doing some analysis of crimes data. What kind of crimes over the last 4-5 years in a particular city in the States. We were analyzing the different crimes, the different types of crimes, at what time of day it was happening, and all that. And we did a lot of things. We did clustering, we did segmentation, we did different kinds of modeling, and we made a presentation where some of the insights were like, okay, theft of vehicles happen outdoors while burglary happens indoors. And this we found out after doing a lot of analysis. And this is like really common sense, right? Of course, vehicles happen outdoor and burglary happen indoor. There's really no analysis which you need to do to come up with that understanding. Yeah, so sometimes you get so involved in the process that you lose sight of what is your goal, what is your purpose of doing all this analytics. So that is where your domain knowledge, your having a domain expert in your team on board is very important, who can always keep the focus in place. Okay. Okay, now coming back to who uses it, almost everyone. Today, all industries, anywhere you look at, there is definitely a potential and a chance for using data. And the domains who are like using it rampantly, these are a few of the domains where it is very popular: banking and financial services, pharma, healthcare, life sciences. That is another area where there is a huge amount of data generated every day. India, probably we are still, evolving in the sense, even at the data collection phase, we need to get to that stage where we are able to collect the data which we need in the pharma and the healthcare space. But in US and all, definitely there is where everything, with EMRs, electrical medical records and EHRs, there is a huge scope of capturing this data and analyzing it. Telecom and retail are two other domains where a lot of this data is being used. Okay, so moving on. These are the different domains where we describe that, business analytics is used very commonly. So who creates it? Who does the analytics? Who creates the models? And what are the skills needed? So let us look into that. Okay. So before we go into business analytics and who does that, what is business intelligence? So this whole space, I would say that business analytics is a part of business intelligence, the subset of business intelligence. Business intelligence is this whole area which starts with collecting the data, extracting that data. So by all these years, by business intelligence, we used to understand data warehousing, or what is it? So collecting data from discrete systems, bringing it together, creating reports, drilling down into the data, and then the analytics involved around it, model building, prediction, everything is business intelligence. And data analytics forms a part of it. So like you see in this diagram here, there is data warehousing, enterprise reporting, performance management, and data mining. Business analytics falls more into the area of data mining here. So it's a set of theories, methods, processes, architectures, and technologies that transform data for business purposes. And here we look into what is data science. So in the slide previous to this, we were talking about what are the skills required for a business analyst, right? And we already mentioned that it's kind of a mixture of different kind of skills. So today, to be a good data scientist, you need to know programming. At least maybe you don't need to be an exceptional programmer, but you absolutely need to know the basics and fundamentals of programming. Because not every time, whatever package or model you use, you can just use it off the shelf. You need to, be able to make your own changes to the code if necessary to, create your own model. So a lot of times and also for data manipulation, for data imputation, a lot of programming skills are often required, right? So you need to have the basics or fundamentals of programming you need to know. Then of course you need to know statistics and you need to know the business. So if you look at the Conway's diagram here, it's a very interesting Venn diagram. which tells us that how these three skills or these three areas which we are talking about correlate, and how data scientists, to be a good data scientist, you really need to fall in that small space where you have knowledge of all three. So let's say you're very good at programming, and you have knowledge of maths, but you don't, or stats, but you don't have domain knowledge. So you may come up with a lot of models and machine learning techniques, etc., but they really may not give that value to the business. The end of it, what do you want to do? You want to derive insights for business, right? So that is the space where machine learning, if you see on top, hacking skills and maths and statistics knowledge, they overlap, but there is no domain knowledge. So you become a very good machine learning expert, but not necessarily a data scientist. Then if you are very good at programming and you have domain knowledge, but you don't know maths. Now see, if you see this, say it's a danger zone, because there are a lot of people who we see in the industry today who probably are, because of all the tools like R and SAS and different packages which are available, and because they know programming, you can just, easily run a regression model or run any complex algorithm without really knowing what is happening inside it. And that is very critical. If you do that, you will get results. The software will make sure you get results, and you might feel very happy about it. But unless you know what the model is doing and whether that's the right model to use, whether that's the right parameter to use, you will get results which really are not correct, or really will not tell you what you need to know. So that's the danger zone, right? You have to be very careful that the statistical methods you are using can actually be applied. Whatever are the criteria for, let's say, today you want to use a regression model, and there are certain prerequisites. That to use this model, your data has to fill these conditions. And that's what statistics tell you. The science of statistics tell you that if you want to use this model, you have to make sure that you have at least, let's say, 1,000 data points. Let's say a simple prerequisite like that. The number of data points has to be at least 1,000. Otherwise, you can't use this model. Let's say I don't have 1,000, but I feel that, doesn't matter. Let me use the model anyway and see what results I get. And I use the model and I get a very nice looking result, and I feel, oh, cool, it doesn't matter. What if I don't have 1,000 data points? It's still working. But then you have broken the premise on which the model is based, right? So you have to make sure that whatever statistical fundamentals are there, you are adhering to that. And the software can't make sure that you do that. That is where your knowledge of statistics comes in. And the other area is stats knowledge and domain knowledge, but no programming. And that's how traditionally people have done data analysis, right? It's only in the recent years that a lot of programming is involved in data science, because we are working with more and more data. We are talking about speeds which are, almost real time at times when you need to run a model. Like, you are all aware of this. Let's say you go to a website, like you go to Amazon.com and you order a book, and immediately you see 3-4 recommendations, right? That you want to buy this book, people have also bought that book, which means even while you are buying, there was some algorithm running at the background which was trying to figure out what are the kind of books that you might be interested in, and throwing out the result in real time, right? Programming is important. Yeah, you can't do that with your traditional approach. Yeah, so that is where statistics and programming comes together. So all these skills together build a data scientist, and which is why it is, even though there are so many people who are trained in stats or maybe programming, it is difficult to get that right mix, and there is so much of a demand for a good data scientist. Yeah. Alright, so I'm just trying to open this link. So if you open this link here, So you can go and play with this link, this data scientist, that Venn diagram which I'm talking about. So it's a very nice Venn diagram, and as you spend more time with it and read through it, you'll really understand what this is talking about. So business analytics, our course is designed around both these areas. One is business analytics, where we don't lose focus of what is the requirement, what is the business need which we are trying to address. Yeah, and data science, where we'll primarily use R for all our data science activities. Some programming skills, of course, we will not be going into deep programming, but we will be writing some small code in R, and we will apply some statistical methods. We will not go into a lot of statistical theory, but I'll encourage you to do that on your own. Understand the theory behind each of the techniques which we apply. And if you have any specific questions about any statistical theory, please send me an email and we can take it offline. We may not have the time to go into the statistical theory in the course itself, but I'll be happy to address any questions which you might have. We will try to look at how these methods are used specific to certain domains. Okay, so what will we learn in this course? We will do some data visualization, and that is one of the very positives or advantages of using R. You can very easily do okay, I think I moved one more slide. You can very easily do some very good visualizations in R with little or no programming. Yeah. Some of the standard data mining techniques which you may be aware of, clustering, association analysis, can be easily done in R. There are packages which enable you to do that. So we will look into that. Maybe a bit later in the program, after the first couple of weeks, we will look into how we can do clustering, how we can do association analysis. What about modeling or regression? Any idea what is regression? Anyone? Why do we do regression? Have you heard about this term? Yeah, regression may be used to predict, but it is used to predict, in fact. But what regression really does is, you want to build a relationship between one variable or one parameter and other parameters, right? Let's say property prices. You can look at it as a simple thing, right? So today you have property, you want to buy a house. Let's say you want to, so you want to buy a property, and there are, you will be given a price, right? Now this price depends on a number of factors. Yeah, of course, the size of the house, the area, the location where you're buying the house, the different facilities which are there in the house, whether there's a club, there's a swimming pool, there's a security. Yeah, so there are many factors on which this price of your house might depend on, and there is no direct relationship. You can't just give very nicely or easily an equation which will tell you that okay, this is how they're related, right? And so regression is basically creating a model or creating a explanation where you can give these as inputs, all these parameters, and it will give you the output, which is the price of a house. And of course, if you go into the theory, you know how this is done. There is linear regression, there are different regression models like stepwise regression, logistic regression. But basically that is what it is. There are a number of input variables and there is an output variables. You want to be able to create some kind of a relationship between them. And once you have the relationship, you can use this relationship to predict prices for houses where you don't know the price, right? So you give all the input parameters, it will give you a result. So that is why it is also used to predict. It is not used to predict relationship between variables, Shiv Kumar. Maybe I would not use that phrase. It is used to predict the result from the input variables. Yeah, and it builds a relationship based on the data. Okay, yeah. Demand forecasting. Yeah, so just like you have regression, There is forecasting, where forecasting is typically used for predicting the future based on historical data. Yeah, so you know the sales for your for a retail store, or for your the sales over a period, over 5 years, over 10 years. You can sort of forecast that, okay, next year I think this is how my sales are going to be. So there will be some increase, there will be some seasonality, certain months, maybe before your Christmas and before your Diwali, there will be a lot more sales. So you factor all these things around in trend and seasonality, and you can forecast. Yeah. Data manipulation, we will look into data manipulation, which is what I was talking about, and this is a very, very important part of your whole modeling. Yeah? How you can, how to prepare your data, how to make it ready for modeling. Yeah? And this is where your, how good you are as a data scientist or as a data analyst comes in. On how much you can, how easily you can make that. And there are a lot of decisions which you have to take during data manipulation. So there will be missing data. Not every data will be available to you. So what do you do? How do you replace the data which is missing? Do you replace the whole row altogether? Let's say there's one parameter which is missing, or do you replace it with some other value? Or do you delete the whole thing altogether? So these are decisions which might affect or impact the output you are getting, or how good your model is fitting. So data manipulation we will look into as well. Yeah. So we will also look into these topics briefly, not going into depth. Yeah. One is infographics, business strategy models, data mining, other techniques in data mining like support vector machine and decision tree, neural nets. So we will briefly know what these things mean, but maybe not go into a whole lot of depth. Web analytics, social media analytics, and social network analysis, right? We might look into a little bit about network analysis also. This slide tells you what is the course methodology. So you are already aware, it's a 6-week course, 2 days, 2 hours. You have some quizzes in class sometimes. Then you have case studies, question and answers, class participation which you all are doing. There will be a group project, and there will be a final exam, and there's a pass criteria, of course. So if you have to score above 65% to get a certificate. Okay.